A few weeks ago, we asked our viewers for their ideas about what to make next. And one viewer suggested we talk about Miranda's patchwork world. That's because this tiny, enigmatic moon has so many bizarre features that scientists think it might have once been shattered into a million pieces and then put back together again. So let us take a closer look at this fractured frozen world and the amazing discoveries that are helping us understand how it came to be. Welcome to this channel. If you're here, you probably love space as much as we do. So we hope you'll consider supporting us through the link in the description below. We'd really appreciate it. Let's start with a bit of a puzzle. When Voyager 1 snapped the first beautiful close-up photos of Uranus's moon Miranda in 1989, it revealed a world covered in giant cliffs, deep canyons, craters, and bizarre jumbled terrain. All these features seemed to be made of ice, and they all appeared to be relatively young, but there was one big problem. Scientists had no idea how such a small and weak body could have sustained such violent geological activity so late in the solar system as history. At first, the leading theory was that tidal flexing from the gravitational forces of Uranus was causing enough heat to bubble up out of Miranda's interior to cause all of those massive cliff-forming eruptions. Basically, Uranus was squeezing Miranda and making her cry. But then scientists realized that the internal structure of Miranda would have cooled off long before now, and that kind of activity shouldn't still be happening. So what else could be going on? To answer that question, we need to travel back in time a bit. In the early days of the solar system, the protoplanetary disk was a wild place. There was so much dust and gas flying around that collisions between objects were frequent. And while most of those collisions would just send a couple rocks flying, some were big enough to shake objects to their very cores. In fact, planetary scientists believe that almost every large object in the solar system experienced at least one giant impact early in history. And Miranda is no exception, but scientists think that she was hit by something really big. The evidence can be found in the strange patterns of Miranda's terrain. This is an example of what scientists call jumbled terrain. The blocks of material here look like they've been sewn together like a patchwork quilt. And within them are cracks and ridges that seem to radiate outwards. See, when a big space rock hits a body like Miranda, it doesn't just blow a hole in the surface. It delivers enough energy to completely break it apart, sending huge chunks of material flying. Those chunks form new craters, but they also get thrown up into great arcs that stretch far above the surface and even farther away. Eventually, gravity pulls them back down, but not in neat piles. Instead, they fall back down in jumbled heaps that spread out over the surface like thick syrup. In some places, the impact can actually hurl material all the way around the body, covering up old craters and obscuring whatever happened there before. So after a big impact, a body like Miranda would look like this, covered in jumbled material and crisscrossed with enormous cracks. But it doesn't stop there. The pieces don't stay broken forever. Gravity slowly starts pulling them back together, filling in the gaps between them. The smaller fragments disappear into the cracks, creating pressure that heats up the ice. The newly melted ice seeps out of the fractures until it reaches the surface, where it cools and hardens. Over time, this process builds up more and more material along the fractures until the whole thing becomes one big mountain range. That's what's happening on Miranda's Verona Rupes, which means spider's web cliffs in Italian. These colossal cliffs are the remnants of an ancient impact that shattered Miranda's crust. But instead of sharp, jagged edges, the crustal fragments formed great tall domes that stretched hundreds of kilometers up from the surface. Then, just like we said, the fragments slowly pulled themselves back together. But instead of smoothing out the surface, they created towering cliffs up to 20 kilometers high. Scientists know this story isn't over yet, though. They can see that the jumbled terrain is actually made of several different layers, which means Miranda has been hit by more than one big rock, and each of those collisions fractured and reshaped the crust in new ways. For example, this area called the chaotic terrain looks like an absolute mess. Huge cracks cut across the surface, cutting through the Verona Rupes and even crossing the giant crater named after the famous explorer Amerigo Vespucci. What's going on here? Well, here's another piece of the puzzle. You see, Miranda isn't just cracked on the outside. Scientists have also detected cracks on the inside. In the mid-1990s, researchers analyzing data from Voyager noticed that the way Miranda's gravity fluctuated as the probe flew past it was inconsistent with a perfectly spherical shape. The gravity readings implied that Miranda had a lumpy shape, like a potato, and that it had a strangely smooth, even slightly concave, gravity well. There was only one thing that could explain this observation, a gigantic crack running all the way through Miranda's core. See, the ice that makes up Miranda's crust isn't rigid. Even today, it behaves like a brittle material. So when it gets hit by a giant space rock, it fractures. But the heat generated by that impact might be enough to warm up the rest of the icy interior, and suddenly it is behaving like a gooey liquid slushy. That liquid slushy can then ooze out of the cracks, allowing the fractured pieces to flop back together like wet noodles. This is called shear failure. It happens when the temperature of a material changes and the rigidity of its structure goes down, meaning it behaves more like a fluid. As the liquid ice oozes out of the fractures, it can reshape Miranda's surface in surprising ways. As the crust slowly pulls itself back together, it can drag the surface with it. That creates these long, low ridges and troughs that stretch for hundreds of kilometers. Eventually, though, the surface can't keep up with the collapsing crust. Some gets dragged under and pushed deep into the fractures, while other bits pop up to create vast, towering domes. That's what's happening in this region called the dorsa and the depressions. The dorsa are tall, spiky ridges that stretch over 2,000 kilometers across the surface. And the depressions are, well, the bits that fell out of the crust and sank into the cracks. It's an incredible testament to the power of shear failure. Look at how neatly the surface appears to have been sliced off and dumped into the gaping fracture in this photo. Now, let's go back to that huge jumbled mess of terrain called the chaotic terrain. Scientists think that a third major impact hit Miranda after all those cracks had already formed. Somehow the fragments of Miranda's crust were broken free and tumbled into the jumbled mess we see today. But if all of this reshaping happened relatively recently, why did it take so long to discover? It's because these processes are surprisingly slow. Even today, Miranda is still coming back together. Scientists think the entire crust is shifting around at about half an inch per year. And the entire process of recovering from a giant impact could take millions of years. And it isn't over yet. Even today, Miranda is still being bombarded by meteorites. In fact, the youngest feature on the moon is this crater named after the intrepid aviator Amelia Earhart. It's only about 50 million years old. That's like yesterday in space. And that means that Miranda's patchwork world is still being written. But you don't have to wait millions of years to explore this fascinating icy moon. Just hop into your spaceship and fly on over. Hey, don't forget to subscribe and get notified when we upload. What do you want to see next? Let us know in the comments, and thanks for watching.